good morning. Thank you for being here. And today I want to present a new product range from ebm-papst. And my name is Uwe Sigloch, and I'm the Director of Product Management in ebm-papst, and I'm based in Germany. And today's agenda is I will tell you a few words about ebm-papst, the company, and then I will present to you the AxiEco product range, a new style axial fan range, and there's also a highlight that we display on our booth this year, the biggest EC motor in the market. And after that, I will close the presentation with some proven savings in retrofit projects. So the history of ebm-papst. ebm-papst is, next year we will celebrate our 60th birthday, and it was founded as EBM, Elektrobau-Molfingen, and in 2003, after acquisition of two other companies, we created the ebm-papst brand. Some highlights were then in 2009, where we introduced the Green Tech label, Green Tech technology. That is, Green Tech stands for being efficient, producing products that help our customers save energy. And we enlarged this approach in 2019 with coming from green, getting into more intelligence. This has to do with exchanging data and monitoring the product. I will tell you about that later on. So ebm is a 2.2 billion euro company with 15,000 people, and we have our headquarters in Europe. So you see that the main activities are in Europe, but we have also production plants in Americas and also in Asia. So the first thing we see quite often in discussions with customers and also with politicians. So what is a fan? So when ebm-papst talks about a fan, we think of a fan system. It's not only the aerodynamic part, like a shaft out fan. We also add the motor and the drive to that fan. So it's always the fan system. And we can say that we are then responsible for what's getting into the fan. This is the power, the electrical power you need to do the job. And from our customer side, we see the airflow and the pressure. And to make this system work as an optimum, as a complete system, optimized system, we have to look into the motor technology, the drive technology, and also in the aerodynamic and acoustics. So starting with the AxiEco, so with the aerodynamic part. So this is a new product, and it looks, for the first view, it looks like an axial fan, but it's some kind of mixture between axial and centrifugal, and we offer this product, we call that design, where you have a basket grill. That is we call it AxiEco Protect. AxiEco, it's Axi stands for axial fan, Eco for ecological fan, energy saving fan, and produce these in diameters 300 up to 910 millimeters. On our booth, we highlight this product. You can walk by the booth and have a look. So what is different compared to an typical axial fan? You see on the top a standard axial fan where you see the blades and the wings. Yeah, you see 5 wings, And when you look at the lower part, the lower picture, you see a complete impeller, and the tip of the wings is connected. So it's an axial fan, but it's installed, when we look at the rotating part, it's installed similar to a centrifugal fan. So when we have a little bit a closer look to that, you see that the stationary part, the inlet cone, is quite short. And the conventional fan needs to have a very long bell mouth to get its efficiency and also its noise performance. But with the newly designed impeller, it's just enough to have a short nozzle, and the rotating diffuser on the impeller helps also to guide the air through the fan. So this is the AxiEco Protect with a short nozzle, and here again the flow direction. It's not typical axial, it's a little bit to the diagonal direction, but then it has less backflow. This can be seen here as well. Here we have the CFD simulation of the fan. On top we have the conventional fan, and everywhere where the color gets towards yellow and red, you see high air velocity. And high air velocity is somehow not good for the efficiency. So the best thing is to have a smooth air velocity situation, a very unified airflow situation, and then the efficiency, you have less turbulences, and so the efficiency is high, and it also, turbulences always means also more noise. So we have also with that system lower noise performance. In respect to air performance, if you have a conventional fan, which is the brown-orange curve, this is more designed for lower pressure. Let's say 150, 200 pascals as a maximum. And with this new impeller, it was specially designed to have a solution when the heat exchanger gets more packed. You have a higher pressure requirement, and this fan is exactly designed for this situation. And you can see we are reaching up to 400 or 500 pascals with these fans. So here a comparison between the different variants. The green curve is here again the AxiEco Protect, and compared to existing fans, you see the pressure level. But more important is what we see on the acoustics. So we have the acoustic part, 500 diameter. We have 4 dB less in the same duty point. So saying this, you don't only have to use this AxiEco at the maximum speed, which generates the highest pressure. It can also use at lower speed, and then the pressure will for sure then be lower, but these advantages in noise and also here in efficiency can also be seen by using this fan at lower speed and lower performance. It will have create very nice subject noise behavior, and you see here it also saves energy. So in this case, compared to existing or the older generation, we save about 9% of energy. So these are 9% points. That means calculating in energy, it's more than 20%. So this is the power range of the AxiEco Protect in the small sizes. And now exhibiting this the first time in Asia, We added other sizes, and these are the sizes 630, 710, 800, and these are, now it must be 630, 800 and 910, and it's for the special use on condensers. So you see here a V-shaped condenser, and these fans can easily be mounted on that without using the long nozzles. So other applications are for air heaters, for heat pumps, especially this is very interesting at the moment in Europe, and also for unit coolers. Unit coolers need quite often a long throw distance and also higher pressure development, and therefore these fans are the right solution. Here's a comparison about our two high runner fans, the standard AxiBlade, which is conventional fan, and the AxiEco Protect, the new fan, and you see same again here, the different pressure ranges what we cover, and you see that we have about a similar efficiency, even though that we don't have a full bell mouth, we only have a short nozzle, and without creating this high nozzle, we have same performance level. And in respect to acoustics, you see that the minimum of the acoustics on the AxiEco is, compared to a conventional fan, shifted more to the left, more to the pressure side. So that AxiEco is not meant to be the successor of the existing conventional fan, it's an addition. So for higher pressure, it's AxiEco. For lower pressure, it's then the conventional AxiBlade fan. So on top of that, we have the AxiEco Protect. As mentioned before, this comes together with a basket guard grill. We have also the so-called AxiEco Perform. Perform stands for performance, and with this fan we have even higher potential in saving energy, means higher efficiency, and also lower noise, because we are integrating in this shape, which you can see on the right side, a guide vane, and then also the guiding the air is more advanced. And compared to the AxiEco Protect, which was already on a high level on efficiency, we add another 7 percentage points in efficiency that at the end pays off, or is efficiency is the wording we are using, but at the end for the user, it's another 25 to 30% energy saving. So the AxiEco Perform is available in the sizes 300 up to 500. So AxiEco Perform, as mentioned, we have the housing, which integrated flange, the motor support is mounted, and also the motor support, the shape of the struts is created in the shape of pressure side guide vanes. So there are different possibilities to use this product. It can be pressure side mounted, as shown on the left. Then in the middle there's the suction side mounted. So depending on the application, it can be fitted to one side of the product or to the other side of the product. And in addition, the position, it must not be horizontal shaft, it could be also vertical shaft, and which is very interesting for the use in greenhouses, for activities in indoor gardening. We have growing crops indoor. On the pressure side, usually for air, you mount a flexible duct. This can be easily fixed to the product. And here on the picture on the right, on the top, there is an application on evaporators in a cold storage room, where you also use, in some applications, textile duct to distribute the cold air in a proper way. So for ventilation purposes, there's also the option to use that in ventilation systems. You can have spiral metal tubes. You just put the fan inside, and you have an inline duct fan. So that was not possible with the fan before, because in inline duct applications you need a certain amount of pressure. But with AxiEco you can easily create this pressure and use it in a duct system as a distribution fan or accelerating fan. So aerodynamics, this we covered, but it's not aerodynamics alone, it's also the drive and the motor, which are responsible to make the product function well, that's one thing, and also be efficient, as the overall efficiency is the product out of drive efficiency, motor efficiency, and impeller efficiency. So we are using EC motors, electronically commutated motors, synchronous motors, permanent magnet motors. These mean all the same thing. Why? And we can say that the EC motor principle is the most efficient principle in the overall motor family that is available in the market. So there are several reasons for that. So first of all, EC motors use permanent magnets, and the permanent magnets are positioned in the rotor. And in conventional motors, you have a squirrel cage, for example, and it needs extra energy to power or to induce a magnetic field in the rotor. But this is not necessary with EC motors, because the magnetic field is already given by the magnets. And we also have to say that we don't use rare earth magnets in our motors. So all our EC motors, even the biggest one, which I will show later, comes with permanent magnets of ferrite made. And another point is that due to the fact that we have in EC motors the so-called single tooth winding, which can be seen on the left, on the bottom, we don't have a lot of copper that has to be where the current has to go through. So you may know the formula or the situation when current has to pass a wire. There's a resistance, and resistance are losses. And you can see the AC on the right bottom picture. There's a lot of unused copper. The copper that is used to create a magnetic field is only the one which is, I would say, inside the slots. And the other one, the copper head, we call it, is ineffective in creating a torque. So this ineffective copper, the current has to go through. So distance, we have losses. And these losses are heat. Means that AC motors are also getting at the same performance, get hotter. than EC motors. And there's another point, EC motors run at synchronous speed, so we don't have slip losses compared to asynchronous motors, where if the 50 Hertz 4-pole speed is 1500, the motor is running at about 1400 RPM. So these are the slip losses, and these generate also heat. So when we compare our position compared to other motor types, there very often we get compared with the so-called IE classes, international efficiency classes. And these classes, or these IE classes, are not meant for EC motors. But anyway, in the marketplace, we get compared to these levels. And we can say that our EC motors are far above IE4. They are, especially in the lower power range, far above IE5 level as well. So whenever these comparisons compared AC and EC are done, the EC motor is the top of the line. So another point with these EC motors, it's simply said, a plug-and-play solution, especially when it comes with a fan. So you can take the whole fan, put some screws, and the fan is fixed in the application. So, and also the wiring is quite simple. You just have to power it. So you have the power line, and you have maybe 2 cables, twisted pair, to operate it via Modbus, for example, or monitor to get data out of the fan. So it's very simple, and commissioning, programming of the electronic is not required, because when a complete fan is delivered, the electronic, the motor, and the impeller are matched together, are tested together. Every product, every part number is tested, and it fits together. Everything is programmed already, so maximum speed, ramp up speed, and all the different things that have to be programmed in with a standalone inverter. You have to go through the parameters and do the programming. But this is all done in the factory. When you have fast switching elements in the network, in the mains, these inverters, EC is similar to an VSD. You have fast switching peaks of voltage, and this create in a motor the situation that you have between the rotor and the stator, you have a voltage. You have a voltage that create a current that can go through the bearings, through the bearing system. You find it quite often when you just match a standard motor AC and an inverter, and after, let's say, 2, 3, 4, 5 months, you see that the bearings get damaged. This has to do with the current through the bearings, and in our EC motors, we have isolated bearing seats, and therefore it's a safe operation. It does not, we don't find these currents through our bearings. Coming to a highlight of this year's exhibition. So this is our biggest EC motor with a torque of 175 Newton meters. Our maximum was before about 70 Newton meters. So, and this is the first, I believe, the first and only motor in that size that includes the VSD drive inside. So it's also EC motor, it's external motor, and it's for standard mains operation, and it's designed for the use in axial fans and in centrifugal fans. Centrifugal fans, there we have a quite high speed. For axial fan application, diameter 1400 up to 2 meters. We have a lower speed design version. And these motors come for safety reasons also with implemented vibration sensors. So you can monitor the vibration situation in the motor. That is helpful for when over the time the fan gets unbalanced due to the, let's say, some wear and some mud or whatever can stick to the impeller. It's monitored, and the information is then given to a system that can trigger some activity, some service activities. So we have, as mentioned, the 175 Newton meters that is shown here, and we have actually this type of motor on our booth. This motor has a shaft on one side and can be used or especially designed for the use on so these are the dimensions. The motor is not, it's quite big, about 100 kilograms of weight. And as shown here, there is a shaft out motor. It's a standard shaft, IEC standard. And it's also plug and play situation as all our product. But in this case, it has to be adjusted to the impeller, because the impeller, axial impeller, it's not part of EBM product range. So this motor is meant to be used for a customer where the customer uses its own aerodynamic. And this is also because 2 meter diameter, it's hard to transport costs are high. So a complete fan shipped over the world is not the thing we wanted to create. But here you see again the same situation at a power line, some monitoring, and that's it. And the fan can be operated. So compared to a standard motor, internal rotor motor needs additional components. So this we see here, we need grounding, we need a separate motor protection. Motor protection is implemented in the motor already on our EC motor. And also when you have an inverter-driven AC motor, you need shielded cable from the inverter to the motor. This is also something we don't need, because the inverter is very close to the motor. Here again, compared to the IE classes, with this motor, the maximum power of this motor is 24 kilowatt. So with the axial, it's not used with 24 kilowatt, it's more for the centrifugal fan use. Axial fans, it's between 7 and 10 kilowatt, for example. But with 24 kilowatt, with this big motor, we reach efficiencies of about 95%. So simple comparison. What does it mean? Just changing the motor, just changing from a conventional motor to a high efficient motor in an existing fan. So we have the conventional fan, AC motor. If it's a 12-pole motor, a low-speed motor, you find about 80% efficiency. You have a transmission with about 90%. You have a VSD efficiency of 96. and an impeller based on static pressure of about 55%. And we did the maths for both motor situations. On the EC side, instead of having 80%, it's 95%. And so you have an energy consumption for the conventional fans of about 44,000 kilowatt hours and 33,000 on the EC side. This is for about 4,000 hours operation per year. So when we look into the cost, Singapore dollars, it's about, I'm not 100% sure, but it must be internet set. We are at about 22 cent, Singapore dollar cent. So we come to a saving of 2,400 Sing dollars in 1 year. And when we do the calculation for CO2 savings, then Singapore is 250 grams per kilowatt hour, roughly. And then we come to 2.7 tons of CO2 savings just using an EC motor in an available application. So it could be a retrofit situation. Good. This is what I mentioned before to make the motor, use of the motor safer. So this graph indicates what happens with the vibrations. So every system, rotating system, has its own frequency where you have a certain peak. So when you run the fan the first time, you go through a procedure. It's an automized procedure. The fan will then ramp up from 0 speed to maximum speed. And by doing this, it measures level, the vibration velocity. And in the future operation, it fades out these critical resonance areas. So the fan will never run a longer time in the critical areas, and this is prolonging the use time, because the load to the bearings when there are vibrations is very high, and it damages over time the bearing system. And by fading out the critical resonances, the lifetime of the motor is prolonged. And on top, it can be also, if you put in a certain limit for unbalance, it also can give an indication to a building management system that service be started, cleaning the impeller or whatever has happened. So this fan, as mentioned, is not from ebm-papst, it's the motor to create an efficient big axial fan. The features I mentioned, the motor has similar features to our standard EC fans. So locked rotor operation, soft start, alarm relay, this is all implemented. So coming to retrofit projects, which we have done in the past years, and it shows a little bit what is possible by using, first of all, efficient components. That's one thing, but also second thing, which is as important, to use the right, or to provide the right amount of air, the right amount of temperature, of heat, the right amount of cold. So it has to do also with the settings of the system, of variable speed drive, use a variable speed drive. It's a lot of savings, and also adjusting the system to the required flow or to the required heat and not overdoing. And here we had a project, it's a genset. So it's cooling big motors producing energy. And just by putting EC fans on the motor, on these coils, the savings was about 90%. But not everything came from the efficient fan. It came also from the efficient use of the fans. Cold storage, evaporators. This is something where you can save energy. You save energy 2 times. One is due to the fact that the motor efficiency, the fan efficiency is higher. And another time because the motor has higher efficiency, it creates less heat. And the heat has to be cooled down in a cold storage. So therefore it's savings 2 times. Another one, it's a data center and a chiller. Here we did also the monitoring over 1 year and the savings, the monitoring graph you can see on the right, on the bottom. So here just by using efficient fan, the saving was 58%. Condenser for data center in Australia. Here also the monitoring was done, not so long, over 2 weeks, but as you can see, the savings quite high, 85%. And here again, efficient product plus efficient use of the product. So this is the key of optimized power use. Okay, I think, yeah, that was the last slide. So thank you very much for your attention. And if there are questions, please, I'm prepared to answer them. Thank you very much.